Dial-up Internet access is a form of Internet access that uses the facilities of the public switched telephone network to establish a dialed connection to an Internet service provider via telephone lines. The user's computer or router uses an attached modem to encode and decode Internet protocol packets and control information into and from analog audio frequency signals, respectively. Dial-up Internet is sometimes used where broadband Internet access is not available, primarily in rural or remote areas. Availability: dial-up connections to the Internet require no infrastructure other than the telephone network and the modems and servers needed to make and answer the calls. Where telephone access is widely available, dial-up remains useful and it is often the only choice available for rural or remote areas, where broadband installations are not prevalent due to low population density and high infrastructure cost. Dial-up access may also be an alternative for users on limited budgets, as it is offered free by some ISPs, though broadband is increasingly available at lower prices in many countries due to market competition. Dial-up requires time to establish a telephone connection and perform configuration for protocol synchronization before data transfers can take place. In locales with telephone connection charges, each connection incurs an incremental cost. If calls are time-metered, the duration of the connection incurs costs. Dial-up access is a transient connection, because either the user, ISP or phone company terminates the connection. Internet service providers will often set a limit on connection durations to allow sharing of resources, and will disconnect the user requiring reconnection and the costs and delays associated with it. Technically inclined users often find a way to disable the auto-disconnect program such that they can remain connected for days. A 2008 Pew Internet and American Life Project study states that only 10% of U.S. adults still use dial-up Internet access. Reasons for retaining dial-up access include lack of infrastructure and high broadband prices. According to the United States Federal Communications Commission, 6% used dial-up in 2010. By 2013, that number had fallen to 3%. Replacement by broadband: broadband Internet access has been replacing dial-up access in many parts of the world. Broadband connections typically offer speeds of 700 kbits or higher for two-thirds more than the price of dial-up on average. In addition, broadband connections are always on, thus avoiding the need to connect and disconnect at the start and end of each session. Finally, unlike dial-up, broadband does not require exclusive use of a phone line, and so one can access the Internet and at the same time make and receive voice phone calls without having a second phone line. However, many areas still remain without high-speed Internet despite the eagerness of potential customers. This can be attributed to population, location, or sometimes ISP's lack of interest due to little chance of profitability and high costs to build the required infrastructure. Some dial-up ISPs have responded to the increased competition by lowering their rates and making dial-up an attractive option for those who merely want email access or basic web browsing. Performance: modern dial-up modems typically have a maximum theoretical transfer speed of 56 kbits, although in most cases 40–50 kbits is the norm. Factors such as phone line noise as well as the quality of the modem itself play a large part in determining connection speeds. Some connections may be as low as 20 kbits in extremely noisy environments, such as in a hotel room where the phone line is shared with many extensions, or in a rural area, many miles from the phone exchange. Other things such as long loops, loading coils, pair gain, electric fences, and digital loop carriers can also cripple connections to 20 kbits or lower. Analog telephone lines are digitally switched and transported inside a digital signal 0 once reaching the telephone company's equipment. Digital signal 0 is 64 kbits. Therefore a 56 kbits connection is the highest that will ever be possible with analog phone lines. Dial-up connections usually have latency as high as 300 milliseconds or even more. This is longer than for many forms of broadband, such as cable or DSL, but typically less than satellite connections. Longer latency can make video conferencing and online gaming difficult, if not impossible. an increasing amount of Internet content such as streaming media will not work at dial-up speeds. Older games released in the late 1990s and up to the early 2000s such as EverQuest, Red Faction, Warcraft 3, Final Fantasy XI, Phantasy Star Online, Guild Wars, Unreal Tournament, Halo, Combat Evolved, Audition, Quake 3, Arena, and Ragnarok Online, are capable of running on 56K dial-up. The first consoles to provide Internet connectivity, the Sega Dreamcast and the PlayStation 2 supported dial-up as well as broadband. The GameCube had an ability to use dial-up and broadband connections, but this was used in very few games and required a separate adapter. The original Xbox exclusively required a broadband connection. Many computer and video games released since the mid-2000s do not even include the option to use dial-up. However, there are exceptions to this, such as Vendetta Online, which can still run on a dial-up modem. Using compression to exceed 56K, the V42, V42BIS and V44 standards allow modems to accept uncompressed data at a rate faster than the line rate. These algorithms use data compression to achieve higher throughput. For instance, a 53.3 kbits connection with V44 can transmit up to 53.3 6 equals 320 kbits if the offered data stream can be compressed that much. However, the compressibility of data tends to vary continuously, for example, due to the transfer of already compressed files. A modem might be sending compressed files at approximately 50 kbits, uncompressed files at 160 kbits, and pure text at 320 kbits, or any rate in this range. Compression by the ISP. As telephone-based 56 kbits modems began losing popularity, some Internet service providers such as Turbo USA, NetZero, .free, Toast.net, and Earthlink started using compressing proxy servers to increase the throughput and maintain their customer base. As an example, Netscape ISP uses a compression program that squeezes images, text, and other objects at a proxy server, just prior to sending them across the phone line. The server-side compression operates much more efficiently than the on-the-fly compression of V44-enabled modems. Typically website text is compacted to 5%, thus increasing effective throughput to approximately 1000 kbits, and images are lossy compressed to 15 to 20%, increasing throughput to about 350 kbits. The drawback of this approach is a loss in quality, where the graphics acquire more compression artifacts taking on a blurry appearance. However, the perceived speed is dramatically improved. The user may be able to choose to view the uncompressed images instead, if desired. ISPs employing this approach may advertise it as DSL speeds over regular phone lines, or simply high-speed dial-up. List of dial-up speeds. Note that the values given are maximum values, and actual values may be slower under certain conditions. References